The last section in Chapter 5, 5.7, will have us focusing on division with polynomials. First of all, we're going to tackle how to divide a polynomial by a monomial divisor. To do such a thing, we can tap into something that we've known for a long time, ever since basic math. In general, if I got a multiple term expression divided by a single term expression, it's always legal in mathematics to break this up into separate fractions. So that's to say I can divide a by d, plus I can divide b by d, plus, and then I can divide negative c by d. Essentially, this property is going to help us divide a polynomial by a monomial. Hold on a second here, a little focus problem. Okay, so let's look at a couple of examples here. So the instructions will probably say divide or simplify. Let's take 10x cubed minus 15x squared. And let's take this binomial and divide it by this monomial 5x. To perform this division, we adhere to the property that we laid out above here, or recognized. That's to say I can put each of these terms in the numerator over the 5x denominator. So let's put the 10x cubed over the 5x plus, and then I can put the negative 15x squared also over 5x. Now all that remains is reducing each of these fractions here. First of all, let's reduce 10x cubed divided by 5x. We seen last week that when we divide like bases, we keep the base the same and we subtract exponents. But first of all, let's divide the coefficients. 10 divided by 5 is 2, and x to the third power divided by x to the first power is x to the 3 subtract 1 power. Now this quotient here is going to be a negative because we have a negative divided by a positive. And plus a negative is the same thing as just saying minus. 15 divided by 5 is 3. X to the second power divided by x to the first power is x to the 2 minus 1 power. Finally, our simplified quotient is going to be 2x squared minus 3x. And we're done with that one. Try this one. 2a cubed minus a squared plus 3a plus 2, and this whole polynomial is going to be divided by 4a. Again, we can utilize this property above by placing each term of the numerator over the denominator. That's to say I can put 2a cubed over 4a plus a negative a squared over 4a plus 3a over 4a plus 2 over 4a. Now to divide, to further simplify rather, we just reduce each of these fractions. So 2a cubed divided by 4a, 2 over 4 reduces down to 1/2. And then we have a cubed divided by a to the first power, which is a to the 3 minus 1 power. Here we have a negative divided by a positive, which this whole quotient will be a minus, so I'll just put a minus. And then we have a squared divided by 4a. Well, a squared divided by a to the first power is a to the 2 minus 1 power. And we still got the 4 down here. Plus 3a divided by 4a. These a's reduce out to 1s. They cancel out or reduce out. And we're left with 3/4. Plus, the only thing we can do with this last fraction is reduce 2 over 4. Notice the a will have to remain in the denominator. So 2 over 4 reduces down to 1/2. So 1 over 2a. And that would be our, well, hold on, we're almost done. Now we just simplify this a little bit further. A to the 3 minus 1 power is a squared. A to the 2 minus 1 power is a. Plus 3 over 4. Plus 1 over 2a. And this is it. This would be your final answer for having divided this polynomial by that monomial there. All right, one more. 10x squared minus 15x squared y plus 25x squared y squared. And we're going to divide this whole polynomial by 5x squared. In keeping with what we've done with all the other previous problems, we're going to split this up into separate fractions, placing 10x squared over the 5x squared. Now we have a minus being placed over a positive. Instead of saying plus or negative 15x squared y over 5x squared, I'm just going to say minus. And then the 15x squared y placed over the 5x squared. Plus 25x squared y squared placed over the 5x squared. Now when you take 10x squared and divide it by 5x squared, this reduces, 10 divided by 5 reduces down to 2, and the x squareds reduce out to 1s. They cancel out. So we're left with 2 as being the simplification of this quotient. Minus 15 divided by 5 reduces down to 3. X squared divided by x squared is 1. That's to say the x squareds cancel out and leave behind factors of 1 understood. And we got the lone y that just has to come along. Plus, finally, 25x squared y squared divided by 5x squared. 25 divided by 5 is 5. The x squareds reduce out to 1s, and we're left with y squared. That, ladies and gentlemen, is your final answer, or quotient, after having divided this trinomial by this monomial. So in general, that shows us how to divide a polynomial by monomial. Basically, again, all you do is you split it up into separate fractions by placing each term of the numerator over your denominator and then reducing the fractions separately. Now we're going to turn our attention to dividing a polynomial by a binomial, which is a lot more involved. To do so, we have to go back and revisit our long division algorithm that we touched base with back in basic mathematics. So let's entertain. How about dividing 2 into 524? This should be review. This is something we did, like I said, way back in basic math. To do so, we ask ourselves how many times 2 divides into 5. Divides in there 2 times. 2 times 2 is 4. Put the 4 down here and we subtract off. 5 minus 4 is 1. We're done with round 1 of division. Now we drop the next digit down, the 2 down, and we set ourselves up for round 2 of division. We ask ourselves, 2 divides into 12 how many times? 6 times. 6 is placed up here in our quotient. 6 multiplied by the 2 is 12, and now we subtract off. 12 minus 12 is 0. Now we're done with round 2 of division. Now we drop down the next digit to 4, and now we have to embark upon round 3 in the final round of our division here. by asking ourselves, how many times does 2 divide into 4? 2 times. 2 times 2 is 4. Subtract off, and we get what's called a remainder of 0. This is your remainder here because there's nothing else to bring down. There's nothing else in the dividend here to bring down to proceed with further division. So your answer to this problem is your quotient, and that's up here. This is your quotient. This long division algorithm with whole numbers is going to be the same type of algorithm that we use to divide a polynomial by a binomial or more termed polynomial divisor. Now this division algorithm is not really difficult per se, but it just has a lot of steps, and because of that you want to practice several of these. So I'm going to go over a couple here. First of all, we're going to try to take x squared minus 5x plus 6, and now we're going to divide this by a binomial x minus 2. Now, ladies and gentlemen, unfortunately, we cannot just use the method we use to divide a polynomial by a monomial. Notice we're dividing by a binomial, not just a monomial. If we were just dividing this polynomial by x, we would just split this up into 3 separate fractions by placing all the terms in the numerator over this x and then reducing each fraction. But we're dividing by a binomial, and because of that, we have no choice but to perform what's called long polynomial division. Long polynomial division. And that is accomplished by using our long division bar. So here's your long division bar that you're familiar with from basic math. Our divisor goes outside the division bar, and that would be the binomial x minus 2. Our dividend is the numerator of this, which is x squared minus 5x plus 6. Okay, to begin, we ask ourselves how many times this x divides into x squared. Now, since this is round 1 of division, I like to do this off to the side of my paper. I like to put 1 indicating this is the first round of division. And I'm going to take this x squared and place it over the x. And now I'm going to reduce this. X squared divided by x reduces down to x to the 2 minus 1 power, or x. So ladies and gentlemen, x is going to be the first term that appears in our quotient. And you'll notice that your author always keeps like terms lined up in columns when performing this long polynomial division. Therefore, since the first term in our quotient is x, the x will be placed over the 5x in the dividend. So we put the x up here. Now this x is going to have to get multiplied by our divisor x minus 2. And I like to also show this little step over here to help me see what I leave underneath here. So x times x will leave behind x squared. X multiplied by a negative 2 will be a minus 2x. Now what we do is we subtract off the whole polynomial. Now, x squared subtract itself is 0. So the x squareds cancel out. A negative 5x subtract a negative 2x. You have to be very careful with your signs. Negative 5 subtract a negative 2. Negative 5 subtract a negative 2 is negative 5 plus 2, which is negative 3. So a negative 5x subtract a negative 2x turns out to be negative 3x. We're done with round 1 of division. Drop down the next term, the plus 6, and now, ladies and gentlemen, we set ourselves up for round 2 of division. This is round 2. And round 2 has us asking ourselves this question. How many times does this x in our divisor divide into negative 3x? To answer that question, let's take the negative 3x and place it over the x off to the side of our paper and reduce this. So negative 3x divided by x reduces down to just negative 3 as these x's drop out. So minus 3 becomes the next term in our quotient, or our answer. So we come up to our quotient and put the minus 3. Now the minus 3 will get multiplied by our divisor, x minus 2. Negative 3 times x is going to give you negative 3x. Negative 3 multiplied by negative 2 is a plus 6. And now what we do is we subtract off this whole polynomial. Excuse me. Make sure, ladies and gentlemen, when you subtract off a polynomial, you enclose the polynomial, the entire thing inside parentheses. Very important. So, a negative 3x subtract itself is 0. So the negative 3x minus a negative 3x is 0x. The 3x's drop out of the picture. They cancel out. 6 subtract 6 is 0. Notice there's no other terms from our dividend to drop down, and so our division algorithm has terminated. So this 0 here is called a remainder. And so, ladies and gentlemen, our answer is our quotient up here, x minus 3. This is your quotient. This is your answer of having divided this trinomial by this binomial. So as you can see, there are quite a few steps, but the key is to remain organized and to practice as many of these as time allows you to do. So, and all should go well. All right, let's try another one here. Let's try to take 2x minus 1, and we'll try to divide it into 4x squared plus 4x minus 3. And again, the instructions will say divide. To begin, we ask ourselves how many times 2x divides into 4x squared. To answer that question, I like to go off to the side of my paper, put 1 to indicate this is round 1 of division. Take the 4x squared, place it over the 2x, and it'll reduce this. So what is 4x squared divided by 2x? Well, 4 divided by 2 is 2, and x squared divided by x to the first power is x to the 2 minus 1 power, or x to the first power. So 2x becomes the first term in your quotient. Take the 2x, place it right here in your quotient above the 4x. Notice we keep like terms lined up in columns when we perform long polynomial division. The 2x now will get multiplied by the 2x minus 1. 2x times 2x is 4x squared. 2x gets multiplied by a negative 1. 2x times negative 1 is minus 2x. And now we subtract off the whole polynomial. Now 4x squared minus itself is 0x squared. In other words, the 4x squareds drop out. And 4x subtract a negative 2x. 4 minus a negative 2 is 4 plus 2. So 4x subtract a negative 2x will be 6x. Will be 4x plus 2x over 6x. Drop down the next term, negative 3 for round 2 of division. Now we ask ourselves, round 2, how many times does 2x divide into 6x? So answer that question, take the 6x, place it over the 2x, and reduce. 6x over 2x reduces down to 3. So plus 3 becomes the next term in our quotient. Now we take the plus 3, we multiply it by our divisor. 3 times 2x is 6x. 3 times a negative 1 is a negative 3. Subtract off the whole polynomial. Notice the 6x's drop out. 6x minus itself is 0. And negative 3 subtract itself. Negative 3 is 0. So again, we're left with a 0 remainder. And your quotient is going to be this guy up here. That is your answer. That is your quotient. So I've shown you so far 2 examples of long polynomial division. Okay, I think I'm going to pause here, and the next video that you will click on will finish this section by looking at polynomial division problems where we have to insert what are called placeholders.